I modeled everything in Python. For the task 1 GUI, I used the Tkinter module. For the solar systems, which are already put on the screen, the parameters fit Kepler's law. For the exoplanet system, I took the data Excel sheet for the 648 planets and used linear regression to get the best line of best fit, plus error bars, because as you can see, the gradient differs from 1, therefore the measurements are not completely exact. Remaining tasks, task 2 to 7, I created another GUI application. To cover task 2 to 5, there's at the top, I modeled the accurate Verlet and Simpson models in dimensions 2D and 3D, supporting exoplanets and our solar system planets. Printing the accurate model, you can see all the orbits in 3D. And then in an exoplanet model, you can see all the orbits. For all the planets except Pluto, the accurate and Verlet model are very similar, whereas for Pluto they are very different due to the eccentricity of the orbit. The solid line shows the accurate model, whereas the animated planets, shows the Verlet model of Pluto and how it differs from the accurate model. For the Simpson model, we choose a higher eccentricity to see it more clearly. You can see how the speed changes in Pluto due to the higher eccentricity of the orbit, how the speed is decreasing right now as the distance from the Sun is changing. However, the Earth's orbit, which is more circular, the speed is remaining more constant. This plot shows how orbital time varies with the polar angle. For the code, this is the solar system and exoplanet data. This is the function for the polar angle versus time. This is the function for the orbit plotter for all planet options. This is the accurate orbit plotter. This is the Simpson orbit model using the Simpson method to calculate. Also the Verlet model. This is task 6, which is the spirograph plotter. Task 7, TRAPPIST distance plotter. As an extension, I created a custom system to explore how different parameters react under Kepler's third law. As you can see here, 3 orbits have formed and 2 orbits have ejected. I summarized all of my results in the draft paper.